Hello and welcome. In this video, we shall see how to find the domain and range of quadratic functions of the form 1 by ax square plus bx plus c. So before we solve actual problems, let us look into some basic concepts. Let us take some quadratic polynomials of this form and let us see how does these functions look. I'll take a very simple quadratic polynomial f of x is equal to 1 by x square. So how does 1 by x square look? So here let me plot this. So let us start with x is equal to 0. If I put x is equal to 0, I'll get 1 by 0 square, which is 1 over 0, which is infinity. So at 0, so it is plus infinity, very large value. And let us put x is equal to, this is x is equal to 0. Let us put x is equal to 1. We get f of 1 is equal to 1 over 1 square, which is 1. So at 1 it is 1 somewhere here. If I put x is equal to 10, let's say put x is equal to 10, you'll get f of 10 is equal to 1 by 10 square, which is 1 over 100, which is equal to 0 0.01. So at 10, it drops down to 0 0.01. If I put x is equal to 100, f of 100 is equal to, I'll get 0.0001, which is very close to 0. If I take x is equal to 100. So what I'm trying to say here is, if you increase x towards infinity, increase x towards infinity, then f of x tends to 0. If x tends to infinity, if x becomes larger value, since it's in the denominator, then f of x tends to 0. So how does the curve look? Does the curve look at the right side? At the right side, the curve starts from infinity and drops down drastically, and finally it reaches 0. So this is the curve. This is how a curve f of x is equal to 1 by x square look uh, at the right side of the vertical axis. Let us put some negative values for x and see how does it look. And now let us take x is equal to minus 1. If you take x is equal to minus 1, you'll get f of minus 1 is equal to f of minus 1 is equal to 1 by minus 1 square, which is 1 over 1. So at 1, again it is, this value is 1. At minus 1, sorry, at minus 1 it is 1. X is equal to, if I put x is equal to minus 10, I'll get f of minus 10 is equal to 1 by minus 10 square, which is 1 over 100, which is 0 0.01. So at minus 10, it comes down to 0, comes close to 0. Similarly, if I put x is equal to minus 100, f of minus 100 will be positive 0 0.0001. So again, it is very close to 0. So what happens here? If x tends to minus infinity, if x is taking very large value at towards minus infinity, then f of x tends to 0 as well. So here also the curve would look like this. So this is the function for f of x is equal to 1 over x square. Now let us take another function which is also very important. f of x is equal to minus 1 by x square. Let us see how does it look. So let us try to draw this as well. If I put x is equal to 0, start with x is equal to 0, I'll get f of 0 is equal to minus 1 by 0 square, which is minus 1 over 0, is minus infinity. So at 0, we have a very large value at the negative side, minus infinity. Let us put x is equal to plus 1. So f of 1 is equal to minus 1 over 1 square, which is minus 1. So at 1, it is minus 1. Let us take this as minus 1. Now if I put x is equal to, let's say, 10, if x is 10, f of 10 is equal to minus 1 by 10 square, which is minus 1 by 100, which is minus 0 0.01. So now if I put x is equal to 10, it is the value of f of x is very close to 0, which is minus 0.01. If you put x is equal to 100, f of 100 is equal to minus 0.0001, which is very close to 0 as well. So what do you mean by this? So if x is increasing, if x is tending to infinity, then f of x tends to 0. So, but important thing is the path it is taking. It is taking path from minus infinity to 0. It goes like this. Similarly, let us take this. Let us write it properly. Similarly, if you let us take, so this will be like this, minus infinity. Similarly, now let us take value of x at the negative side. We can take x value negative also, because the domain is entire real number except x is equal to 0. So let us take x is equal to minus 1. If I take x is equal to minus 1, f of x is equal to f of minus 1. F of minus 1 is equal to minus 1 by minus 1 square, which is minus 1 by plus 1, which is minus 1. So at minus 1, the value is again minus 1. At 0, it starts from minus infinity. If you put x is equal to minus 10, f of minus 10 is equal to minus 1 by minus 10 square, which is minus 1 over 100, which is minus 0.01. So it is very close to 0. At minus 10, it is minus 0.01. If you put x is equal to minus 100, f of minus 100 is equal to minus 0.0001, which is very close to 0. So what I mean here is, if x is going towards minus infinity, f of x will go towards 0, but the path is from minus infinity to 0 like this. So this knowledge is very important for us. Let us summarize what we did. If I have f of x is equal to 1 over x square here, then the curve would look like this. At 0, it takes plus infinity. From plus infinity, it goes to 0. Minus in the negative, in the second quadrant, or when x is negative, it starts from infinity again and goes to 0 towards left like this. Similarly, if I have f of x is equal to 1 by x minus 1 whole square, how does the curve look? The curve will look like at x is equal to 1, it is infinity. So at x is equal to 1, it is infinity. So if I draw a line like this, at x is equal to 1, it is infinity. So from 1, it goes to 0 like this, and from here, it goes to 0 like this. So this is what f of x is equal to 1 by x minus 1 would look like. Let us take negative values. I'll take f of x is equal to minus 1 by x square. Minus 1 by x square would look like this. So at 0, it is minus infinity. So from minus infinity, it settles down to 0, and at the negative x-axis also goes to 0 like this. If I have f of x is equal to minus 1 by x minus 1 whole square, then the value is infinity at x is equal to 1. So at x is equal to 1, the domain does not exist, so x cannot be equal to 1. So at 1, it is infinity. 1, it is minus infinity. So let us see how does it look. So at x is equal to 1, should draw a dotted line like this, and from here, minus infinity goes to 0, and from here it goes to 0 like this. So this is my x is equal to 1. So this knowledge is important for us to proceed. with the problems having the quadratic functions in the denominator. Next video, let us solve some problems. Thank you.